All right, this is 10.3 compound interest, which is different from simple interest, where simple interest will take the interest and collect it only on the amount that's invested. Compound interest takes interest on the amount, but then adds it back into it, and then there's a new principal that's applied. So we're going to look at how we would figure this out doing it simple interest wide. So what I'm going to do is I'm going to make a table here, and then we're going to see that there is a lot easier way to do this problem. So we have Mrs. Moeller who received a $1,000 bonus, and she's depositing it that's paying into something that is compounded quarterly. So we are going to have 4 quarters, and I'm just going to label them as such. And each quarter, the principal is going to change. So we are going to use the simple interest formula for the first one because interest is always equal to principal times rate times time. So just to make a few notes, my rate is 2%, which converts to 0.02. My time is a quarter of a year, which is 0.25. And my principal for the first quarter is this $1,000 bonus. So now I'm going to figure out my interest. Interest is 1,000 times 0.02 times 0.25. And when I multiply that out, I am going to get $5. Okay, so the first quarter I earned $5 of interest. So now in my account, I have $1,000 plus $5. So I have $1,005. This becomes my new principal for the next quarter. So principal is now $1,005. Rate is still 2%. Time is still 0.25. So the interest for the second quarter takes the new principal and multiplies all of this out. So 1,005 times 0.02 times 0.25 comes out to be 5.025, which since we're dealing with money, rounds to $5.03. So at the end of the second quarter, I have the $1,005 plus $5.03. So I now have $1,010.03, which becomes the principal for my third quarter. And the rate is still 2%, and the time is still 0.25. So when I take $1,010.03 times 0.02 times 0.25, I get, let's see, 1,010.03 times 0.02 times 0.25, I now get 5.050, which is going to round to $5.05. So at the end of the third quarter, I have $1,010.03 plus $5.05, and that gives me $1,015.08, which becomes my new principal in quarter 4. And my rate is still the same, and my time is still the same. So the interest on the last quarter times the rate times the time gives me $5.08 because it comes out to 5.0754. So at the end of the first year, I will have, add this together, I end up having $1,020.16. So as before, I would have only accrued $5 if I was just doing simple interest, and then it would just be based on that, $5 every quarter. But because I am doing compound interest, I add that interest that's earned for that quarter into my principal, and that becomes my new principal. Now, this is fine if you're just doing it for a year, but let's say I invested for 10 years. I would have to do this 40 calculations. So we don't want to have to do that. So we have a formula that we are going to use for this test. So you notice that there is a new number involved in this formula, and that is n. And n is the number of compounding periods per year. So if it's annually, n is equal to 1. If it's semi-annually, n is equal to 2. Quarter, there's 4 quarters in a year. Monthly, there's 12 months in a year. And daily, remember we use the banker's daily, which is 360, not 365. Okay, so we're going to use this formula and now plug it in. And really, what you're going to be doing is this is just a calculator operation. I'm going to show you how to write it out. Then I'm going to show you how to write your steps using the calculator. So first and foremost, identify this is your principal. This is your rate, which I'm going to write as 0.018. It's compounded monthly, so n is 12, and then time is years, okay? So if I write out my formula, A is the principal times 1 plus the rate divided by n times n raised to the n times t power. So what I find is helpful is I list all these things. P is 3,000. R is 0.018. N is 12. T is 2, and then I go ahead and calculate the n times t exponent, which gives me 24. That kind of saves me a step of entering in the calculator. So now I'm going to write A, which stands for the accumulated amount, is 3,000 times 1 plus 0.018 divided by 12 raised to the 24 power. Now, if you have a graphing calculator and you enter it just like that, you will get the correct answer. What I find students do is that they make errors on this because they don't enter things in the proper steps. So what I'm going to tell you to do on a scientific calculator, I'm going to have you start here. You're going to enter 0.018 divided by 12 plus 1, and then I hit enter. Now, sometimes it will give you a very long decimal, and I'm going to say just leave it on your calculator. So right now, what I see on my calculator is this, okay? Then I'm going to use the caret top, or the exponent key, and raise it to the 24th power. Here you're going to see an extremely long decimal. I'm just going to leave it on that calculator, and then I'm going to multiply it by 3,000. And so I'm going to get 3,109.883. And so I'm always going to round to 2 decimal places. So make sure you write that, round to 2 decimal places, okay, since we're dealing with money. And that's it, okay? So at the end of 2 years, I will have earned $109.88. And that's what they're just asking you for the amount that will be in this account. Now, sometimes they'll have 2 parts to the problem, like these next ones. You'll have to find the A, which is the accumulated amount, and then you will have to find the interest, which the interest is always the accumulated amount minus the principal. Okay, so as I go through my chart, I change my percent to a decimal. I write my N as 1, my T is 3, and then I write N times T, which is also 3. So now I write my formula. 8,000, 1 plus 0.06 divided by 1 raised to the third power. So as I enter this in my calculator, I am going to get 8,000, $9,528 and 0.128, which will round to 13 cents. And then my interest, I simply take and subtract the $8,000 that I invested, and that says I earned $1,528.13. Okay, all right, so rate is 0.04, semi-annually is 2, and time is 5. So N times T is 10. So you will take your 4,000, 1 plus 0.04 divided by 2 raised to the 10th power. So as I do this on my calculator, again, I always start with this 0.04 divided by 2 plus 1, then I hit equals, then I raise it to the 10th power, and I hit equals, and then I multiply by 4,000. And so I should have 4,875.977, which makes that 0.98. And so my interest says that I will subtract out the 4,000 that I invested, and I earned $875.98 of interest. Okay, so basically all these problems are the same. It's just changing the rate, the principal, just changing the numbers basically. So 0.08, N is 4, T is 6, so my N times T is 24. And I like doing that because it just saves me from having to enter extra parentheses into my calculator. So the accumulated amount is 2,500. 1 plus 0.08 divided by 4 raised to the 24th power. So I get this, and whoops. Okay, raised to the 24th times 2,500, and so I'm going to get 4,021.09. And then my interest, go ahead and take out the 2,500. So 5 from 10 is 5. So 1521.09. So I'm just going to pull up my notes here. All right, so let's try the next one. So 0.065, monthly is 12, time is 4. 12 times 4 gives me my 48. So A is 2,500, 1 plus 0.065 divided by 12 raised to the 48th power. All right, so let's see what we get when we look at this problem. As I go through, just checking to make sure I have So as I multiply this out, I'm going to get $3,240.05. And then when I find my interest, I subtract out the $2,500 that I invested. And that tells me that my interest is $740.05. Okay, and the last one, I believe what we're going to do using this formula is daily. So change your rate to 0.055. Daily is 360. And then N times T is 360 times 20, which gives me an exponent of 7,200. So you think if you were doing this by hand, you would have to do 7,200 calculations. But thank goodness we don't have to do this by hand. So A is equal to 25,000, 1 plus 0.055 over 360 raised to the 7,200 power. And so when I calculate that out, that says at the end of 20 years, I will have $75,097.84. And when I figure out my interest, I will take out the 25,000. And so that says I've earned $50,097.84. Now, the next ones that we're going to be looking at are dealing with present value. So this is the blank that needs to be filled in. And so this formula is very complicated to enter on the calculator. So what I'm going to do is I'm going to show you another formula. And it's going to look very similar to the one that we used the last time with one exception. Remember we talked about negative exponents, and if you have a positive exponent in the bottom, you can move it up to the top and that will make it negative. So that's a lot easier to enter on our calculator than it is to enter the formula that's given and try to keep all those parentheses set, okay? So what I'm going to do is I'm going to enter my principal is, it's not my principal, excuse me, my accumulated amount. So what I need to make is $30,000, okay? And so this formula is going to be useful when you're trying to save up for very big things like a house or a car or a wedding or something that you know is going to be very expensive. My rate is going to be 2.5%. So I'm going to write 2.5%, which is 0.025. My N is compounded. It says, let's see, where does it say? Compounded quarterly. So N is 4. And my time is 6. So this is the difference. I'm going to figure out negative N times T, which becomes negative 24. So my present value, this is what I need to invest now so that I will have $30,000 in 6 years. So I take 30,000, 1 plus 0.025 divided by N, which is 4, raised to the negative 24 power. And that negative 24 power is what's going to help me figure out how much I have to invest. And so when I punch this in my calculator, I am going to get $25,833.30. Okay, so this is only used, the negative will only be used when they want to know the investment now. So now means negative exponent, okay? All right, so we're saving up for a tractor, or anytime it says saving, that means that what do we have to invest now to get that ending amount, okay? So the accumulated amount that he wants to accrue is $276,000. The rate that he's investing is 3.6%, which is 0.036. The N is compounded monthly, so there's 12 months in a year, and the time is 5 years. So negative N times T is negative 60. So the present value is 276,000 times 1 plus 0.036 divided by 12 raised to the negative 60 power. And that tells us that he has to have, or the present value that he needs is 230,596.71. And the last one we're going to do, we've got our accumulated amount. He wishes to have $20,000 available to him. The rate is 1.55%, which is 0.0155. The N is going to be, he's compounding it quarterly, so N is 4, and T, 18 years. He wants it available to him in 18 years. So negative N times T comes out to be negative 72. Okay, so the present value is $20,000 times 1 plus 0.0155 divided by 4 raised to the negative 72 power. And when I punch that in, that says we have to invest $15,138.96. And that finishes up 10.3.